Hello again. We have heard in the last units about biotechnological production of vanillin, the most important flavor molecule, the gamma and delta lactones, and the terpenes. Today we will have a look at another important group of flavor molecules, the so-called green notes. These are aliphatic alcohols and aldehydes, with a chain length from C6 to C9. Some of them are unsaturated. The flavor is described as freshly cut grass, cucumbers, green apples, or foliage. The biotechnological process for all of the compounds is similar. In the first step, the polyunsaturated fatty acids, linoleic and linolenic acid, which can be obtained by the enzymatic hydrolysis of linseed oil, are oxidized by lipoxygenases to 9 or 13 hydroperoxy acids. The next step is the breaking of a chain by the action of a hydroperoxide lyase. By this, the aldehydes are obtained, which can be reduced to the corresponding alcohols by an alcohol dehydrogenase. Fresh soybean flour is commonly used as a source of lipoxygenase for the production of 13 hydroperoxy linoleic acid and 13 hydroperoxy linolenic acid. Unfortunately, this enzyme has also an 9-hydroperoxide lyase activity. These acids are then transformed by a hydroperoxide lyase from guava fruits or leaves into hexanal or set-free hexenal, which can isomerize to E2-hexanal. Also, the leaves of watermelon or sugar beet contain high hydroperoxide lyase levels. Several groups have also worked on recombinant microbial strains which contain these enzymes. Using a lipoxygenase with a high 9-hydroperoxide lyase activity from cucumber, for example, nonenal and 2,6-nonadienal can be obtained. We will hear about the successful commercial application of these processes from Peter van der Schaft from Axence in the next video. His examples show that also plant enzymes directly out of fruits can be used for the production of flavors. He will also give some indications about the amounts and prices of these products. But there is also a lot of other interesting molecules. Another group are the so-called fruit esters. Fruit esters are formed from short-chain alcoholic and carboxylic acids. The figure shows you some examples of different esters with their flavor descriptions. As you can see, the smell is typical for different fruits. The esters are obtained by the enzymatic esterification of a natural alcohol with a natural carboxylic acid. This is done in organic solvents with lipases. Very frequently, Candida antarctica lipase B is used, which is also sold as an immobilized enzyme. Ethanol can be easily obtained from the alcoholic fermentation with Saccharomyces cerevisiae. Other alcohols are constituents of fusel oil, a byproduct of alcoholic fermentation and degradation products of amino acids. The alcohols can be isolated by distillation. For acetic, propionic, and butyric acid, classical fermentation processes are known for a long time, but the processes last relatively long and the product concentration are not that high. Here, a biotransformation process gives much higher titers in a shorter time. In this case, the alcohols are oxidized with selected strains of Gluconobacter. Here, product concentrations of about 90 grams per liter can be reached within a few days. In addition, it is possible to obtain carboxylic acids for which no traditional processes are available, like isobutyric acid and isovaleric acid from isobutanol and isoamyl alcohol. In addition to the use as starting materials, the alcohols and acids are also flavor molecules of their own, as we can see in the flavor descriptions of the molecules. We have seen during these lectures that the flavor molecules possess a broad chemical variety, but all of them is in common that they consist only of carbon, hydrogen and oxygen atoms. But also sulfur and nitrogen containing molecules are very strong flavor molecules. Some examples of the sulfur containing flavor molecules can be seen in this chart. As you can see, these are partially quite unusual structures, and the biochemical access to these molecules from natural ingredients is not that easy. If you have any ideas, you are invited to contact me. The same is true for the nitrogen-containing molecules. Here you see some pyroxenes and their flavor descriptions and odor threshold values. Again, if you have any ideas how to obtain these compounds naturally, please contact me. Here we are at the end of a bioflavor unit, and I hope you got an impression of the diversity of this very special area of bioeconomy. Goodbye.